I'm Suchindra, and this is my final assignment submission for ML Foundations for Product Managers course with Coursera and Duke University. The final assignment involved forecasting the energy output for combined cycle power plant. The input variables are temperature, ambient pressure, relative humidity, and exhaust vacuum. The predictive value that we are trying to get is electrical energy output. The way I went about it is I used Vertex AI, which is the machine learning tool from Google. I uploaded the CSV file. Upon reviewing the uploaded data, there were 5 columns and approximately 9,500 rows. There was no data missing from the table. So once we have the data, we can start training the machine learning models using AutoML in Vertex AI. Now, given that we need to decide which machine learning algorithm to use, since we're dealing with numerical values, which are sensor readings and power output, we cannot use classification because this is not a classification problem. So we are going to use regression for our training models. For splitting the data, I chose to do 3 models, but I chose to split the data in the same way for all 3 models, which is random assignment of data from the data set. And we use 80% for training, 10% for validation, 10% for test, which I believe is a common strategy and is also recommended by Google in this case. Now, for the model creation, the dataset provides 4 features that we have to use to predict the target variable. I created 3 models. For the first model, I used RMSE as the optimization objective and all the features in the dataset as training features. For the second model, I used MAE as the optimization objective and again, all the features that were there in the model. And for the third model, upon looking at the first 2 models, MAE model had performed better. So I stuck with the MAE model for the third model, and I excluded 2 features, ambient pressure and relative humidity, which I thought may not be that important. So I used only 2 features, which is temperature and V. The models were trained for 2.5 hours each. Now, in conclusion, the model that showed the best performance was Model 2, which used the regression model optimized for MAE. Notice the performance of the models in the table. The model in the middle showed the best performance in all features. The MAE score is 2.22, which is the lowest of the 3 models. MAPE is also the lowest, even RMSE is lowest, and the R squared was highest in Model 2, which is 0.969. So across the board, Model 2 was the most effective. In feature performance, all are very consistent in terms of feature ranking. Overall, it's a great project. Very happy with the use of Vertex AI. Thank you.